I am Radhakrishna, mathematics teacher. We are going to continue our definite integration. This is 9th lecture. In last class we have discussed reduction formulae or Wallis formulae. Now we solved some problems. Now we are going to discuss some more results in reduction method. That is, in last class we have discussed integral sin power nx dx between limit 0 and pi by 2 and integral 0 to pi by 2 cos power nx dx and integral 0 to pi by 2 sin power mx cos power nx. Now, if it is tan power nx, the limit should be 0 to pi by 4. For sin and cos, standard limits are 0 to pi by 2. For tan x, it is 0 to pi by 4. Then the reduction formula will be In is equal to 1 by n minus 1 minus In minus 2. Let us see how. In indifferent integration, if In is equal to integral 0 to, in indifferent integration, if In is equal to integral tan power nx dx, what is the reduction formula? Tan power n minus 1x by n minus 1 minus I n minus 2. We have proved it. Now, if you take limits 0 to pi by 2, pi by 4, here in the first term take limits 0 to pi by 4, then you will get, substituting pi by 4, you will get tan pi by 4 1, so 1 by n minus 1, and substituting 0, tan 0 is 0, so it is 0. So this first term is 1 by n minus 1 minus I n minus 2. So that is the reduction formula. So if you go on reducing the value of n by 2 by using this formula, finally if n is even, you will get I naught as the last term. If n is odd, you will get I1 as the last term. What is I naught? If n is 0, if this is 0, then tan power 0x is 1. Integral 1 dx between limit 0 and pi by 4 is pi by 4. I naught is pi by 4. And I1 is integral 0 to pi by 4 tan x dx. Integral of tan x is what? Integral 0 to pi by 4 tan power 1x. This is I1. Integral of tan x is log mod secant x. And substituting limits 0 and pi by 4. Secant pi by 4 is root 2. So you will get log root 2, and substituting 0 you will get log 1 0. So log root 2 is nothing but half log 2. Okay. Similarly, if In is equal to integral cot power nx dx, for cot power nx standard limits are pi by 4 to pi by 2, and using the reduction formula in indifferent integration, In is equal to integral cot power nx dx is equal to minus cot power n minus 1x by n minus 1 minus I n minus 2. This we have proved this result. Now substituting the limits 0, pi by 4 and pi by 2, you will get this result. This is same as integral 0 to pi by 4 tan power nx dx is equal to integral pi by 4 to pi by 2 cot power nx dx. And similarly, if In is equal to integral secant power nx dx, limit should be 0 to pi by 4. What is the formula in indifferent integration? If In is equal to integral secant power nx, then the reduction formula is secant power n minus 2x into tan x by n minus 1 plus n minus 2 by n minus 1 into I n minus 2. This is the reduction formula. Now, if you substitute the limits 0 to pi by 4, here 0 to pi by 4, then secant pi by 4 is root 2, so root 2 power n minus 1 into tan pi by 4 is 1 by n minus 1, substituting 0, tan 0 is 0, so the term is completely 0, plus n minus 2 by n minus 1 into I n minus 2, this is the reduction formula. And similarly, integral 0 to pi by 4 secant power n x dx will be equal to integral pi by 4 to pi by 2 cosecant power n x dx. Okay. Now, let us solve problems on the other models other than sin power n x, cos power n x. Integral 0 to pi sin of n plus half into x by sin x by 2. In this model, the approach is take the given integral as in. In is this. Immediately find the difference between in and in minus 1. In minus 1 will be, both the integrals will have same limits, 0 to pi by 2, 0 to pi. Denominator is not containing n, so it will be same in both the integrals. So, I will write the common denominator sin x, and in in numerator is sin of n plus half into x minus in in minus 1, replacing n by n minus 1, you will get sin of n minus half into x dx. Now, what is sin c minus sin d? 2 cos c plus d by 2 sin c minus d by 2, integral 0 to pi 2 cos c plus d by 2 is this plus this by 2 will be nx into sin c minus d by 2. Oh, sorry, this is denominator is sin x by 2. Two cos c plus d by 2 sin c minus d by 2, this minus this by 2 will be x by 2 by sin x by 2 dx. What happens? Sin x by 2 cancels. Then what is the integral of 2 cos n x? 2 into sin n x by n. Substituting the limits 0 and pi, sin of n pi is 0, substituting upper limit pi, sin of n pi is 0, where here in all these problems, wherever n is there, you should understand that it is an integer. So, if n is an integer, sin of n pi will be 0, and similarly substituting 0, it will be 0. So, this is completely 0. In minus 1 is 0 means in is equal to I n minus 1 for all n. Here, if in is equal to in minus 1 for all n, then I naught is equal to I1 is equal to I2 is equal to every I is same. So, to get the value, I will write in is equal to I0, I naught. Putting n is equal to 0, what happens? Sin x by 2 by sin x by 2, it will become 1, integral 0 to pi 1 dx. Integral of 1 is x, and substituting the limits, you will get pi. So, the value of this integral is pi, and we will solve similar questions with the same approach almost. Evaluate integral 0 to pi by 2 sin 2nx by sin x into cos x. In this question, we can write sin 2nx by sin x as a sum of a series. If you take cos x plus cos 3x plus cos 5x plus and so on cos, see what is the nth term of the series? Odd multiples of x. So, nth term will be 2n minus 1 into x. Consider this series. Let us find this sum. If you want to find this sum, you should multiply and divide by 2 sine common difference by 2. For finding the sum of a series of cosines, this is the approach. If the angles are in AP, then multiply and divide by 2 sine d by 2, where d is common difference. What is the common difference of the angles here? 2x. X difference between 3x and x, or 3x, 5x and 3x is 2x. So, common difference is 2x. So, 2 sine d by 2 means 2 sine x. So, we have to multiply and divide by 2 sine x. And divide by 2 sine x. Now, taking 2 sine x inside, two sin x cos x is sin 2x plus 2 sin x cos 3x. 2 cos a sin b is cos of a plus 2 cos a sin b is sin of a plus b minus sin a minus b. So, 2 sin x cos 3x will be sin of a plus b means 3x plus x 4x minus sin a minus b means 3x minus x 2x. This is second term. Similarly, multiplying 2 sin x and cos 5x by transformations, it will be again sin a plus b plus sin minus sin a minus b. A plus b is 3x plus x 6x minus a minus b is 5x minus x 4x and so on. Last term is 2 sin x into cos 2n minus 1 into x. Again sin a plus b minus sin a minus b formula. Sin a plus b means 2n minus 1 into x plus x will be 2nx minus sin of this minus this is 2n minus 2 into x. Now, it has become a telescoping series. Sin 2x cancels, sin 4x also cancels, sin 6x cancels. Similarly, in the last term, second part will cancel out. So, what is the sum? It is only remaining term is sin 2nx by sin x, 2 sin x. Now, we will substitute sin 2nx by sin x as 2 times this. Okay. Then the given integral is say in. In is equal to that sin 2nx into sin x is 2 times this and into cos x is also there. So, 2 integral 0 to pi by 2 cos x into this sum cos x plus cos 3x plus cos 5x and so on cos 2n minus 1 into x dx. Then multiplying by 2 cos x, 2 cos square x will be 1 plus cos 2x. Okay. Next is 2 cos x cos 3x, 2 cos a cos b is cos of a plus b plus cos of a minus b. So, cos of 4x plus cos of 2x plus next term is 2 cos x into cos 5x will be cos of 6x plus cos 4x and so on. Last term 2 cos x into cos 2n minus 1 into x will be cos 2nx plus cos 2n minus 2 into x dx. Now, integrating, what is the integral 0 to pi by 2? 1. Integral of 1 is x, substituting the limits you will get pi by 2. Integral of the first term is pi by 2 plus integral of cos 2x is cos 2x plus integral of cos 2x is sin 2x by 2 between limits 0 and pi by 2. Next is cos 4x, integral is sin 4x by 4 between limits 0 and pi by 2. In this way you will write all the integrals. Now, if you substitute pi by 2 you will get sin pi which is 0, substituting 0 also it is 0. So, this is completely 0. Similarly, here also substituting pi by 2 you will get 0, substituting 0 also you will get 0. In this way all these integrals will become 0. So, the answer is In is equal to pi by 2. Okay. Next question, show that In is equal to integral 0 to pi 1 minus cos 2n cos nx by 1 minus cos x dx is equal to n pi. Here let us follow the same approach. In is equal to integral 0 to pi 1 minus cos nx by 1 minus cos x dx. Now, let us take In minus In minus 1. This is the general approach. In minus 1 will be integral 0 to pi, this is common, integral 0 to pi is common in both the integrals. Denominator does not contain n, so denominator is also common. And what will be the numerator? 1 minus cos nx minus of 1 minus cos n minus 1x. You will get cos n minus 1x minus cos nx. Okay. Now, what is cos c minus cos d? Integral 0 to pi cos c minus cos d is 2 cos 2 sin d plus c plus d by 2 into sin d minus c by 2. C plus d by 2 is what? 2n minus 1 into x by 2 into sin c d minus c by 2. This minus this by 2 will be x by 2. Since you got sin x by 2, you write the denominator 1 minus cos x as 2 sin square x by 2. Then 2 cancels, sin x by 2 cancels. So, we got integral 0 to pi sin of 2n minus 1 into x by 2 by sin x by 2 dx. And this is in the form of our first question today, today's first question. Taking half inside, sin of n minus half into x, and our see the first question, sin of n plus half into x divided by sin x by 2. We have proved that it is a constant pi for any value of n. Okay. Similarly, this will be a constant and its value will be pi, even if it is 2n minus 1, n can be any integer, no. So, if you replace n by n plus 1, it becomes that question. So, we have proved that this is pi according to the first question. In minus 1 is constant, means the difference of consecutive integrals will be constant. Then what can you tell? I1, I2, I3, I4 and so on up to In, if you take, all these integrals will be in arithmetic progression with common difference pi, is it not? Because I2 minus I1 is pi, I3 minus I2 is pi and so on. Okay. So, if you want In, you calculate I1. I1 is equal to, putting n is equal to 1 in the given integral, numerator is 1 minus cos x, denominator is also 1 minus cos x. So, it will be integral 0 to pi 1 dx. What is its integral? Pi. Integral of 1 is x, substituting the limits you will get pi. If I1 is pi, what is I2? Pi plus pi. Every integral increases by pi units. Therefore, if I1 is pi, I2 is 2 pi. I3 is 2 pi plus pi, 3 pi and so on. So, what will be In? In will be n pi. So, we have proved. Okay. Proceeding to next question. Integral 0 to pi, it is not pi n, it is pi. Integral 0 to pi sin square nx by sin square x. Denoted by In. Approach is same. Find In minus In minus 1. In minus I n minus 1 will be integral 0 to pi sin square nx minus sin square n minus 1 into x by sin square x dx. What is sin square a minus sin square b? You know the formula, sin square a minus sin square b is sin a plus b into sin a minus b. Integral 0 to pi sin of a plus b means 2n minus 1 into x into sin of a minus b means x by sin square x dx. Now, sin x cancels, remaining is integral 0 to pi sin of 2n minus 1 into pi by sin x dx. Now, you see the previous questions. In the previous question, we got this as pi, no? If you multiply x by 2, it becomes this one. So, if you want to multiply x by 2, what should you do? You should multiply the integral by 2 and divide the upper limit, divide the limits by 2. So, this will be equal to, or here you divide x by 2. If you want to divide x by 2, then we have to divide the integral by 2 and divide, multiply the limits by multiply the limits by 2. So, you will get 0 to 2 pi sine of 2n minus 1 into x by 2 by sine x by 2. Now, here substituting pi minus x, it remains same, whole function remains same. So, we can multiply this integral by 2, divide the upper limit by 2. Okay. Now, next this will be half integral sine of 2n minus 1 into x by 2 by sine x by 2, multiplying these limits by 2, then you will get new limits as 0 to pi only. Okay. But here in the previous question, what are the limits? 0 to pi only. So, this is what? Pi. So, this is pi into half will be pi by 2. In minus 1 is pi by 2. That means again all i's are in AP. I1, I2, I3 and so on are in AP. So, let us calculate I1. If you put n is equal to 1, what is I1? Integral sine square x by sine square x is integral 1 dx. Substitute integral 1 is x, substituting the limits you will get pi. So, I1 is pi. What is I2? I2 will be I1 plus, what is the difference you got? Pi by 2. Oh, 2 we forgot 2. So, multiplying by 2, it will be pi only. Okay. So, I2 will be 2 pi, I3 will be 3 pi and so on. So, In will be n pi. Okay. Next question, evaluate 5050 integral 0 to 1 1 minus x power 50 whole power 100 by integral 0 to 1 1 minus x power 50 whole power 101 dx. If you observe the numerator and denominator, limits are same, base function 1 minus x power 50 is same, only power is 100 here and 101 here. So, in place of 100 or 101, if you take n, you will get integral 0 to 1 1 minus x power 50 whole power n. If you denote it by In, then these two are in the form of In minus 1 by In or In by In plus 1. Okay. Take the bigger number as n. So, this is In, that will be In minus 1. That means, we have to find the ratio of In minus 1 and In. So, let us find this in terms of In minus 1. Here this is completely algebraic function, so approach is different. We will integrate it by parts. But where is the first function, where is the second function? First function is 1 minus x power 50 whole power n, second function is 1. Then you will get first function into integral of the second function is integral 1 x minus integral derivative of the first function is n into 1 minus x power 50 whole power n minus 1 into derivative of 1 minus x power 50 is minus 50 x power 49 into integral of the second function is x. So, this becomes x power 50. I will write into x dx and take limits 0 to 1 here and 0 to 1 here. Substituting 1, it will be 0. Substituting 0 also, it will be 0. So, cancel it. This is minus of this minus is plus. Take out the constant 50 into n, 50n. 50n integral 0 to 1, this is x power 50, 1 minus x power 50 whole power n minus 1 into x power 50. Now, we want to write this in terms of in minus 1. Okay. If x power 50 is not there, it is in minus 1. But how to get rid of that x power 50? You can write this as integral 0 to 1, 1 minus x power 50 whole power n minus 1 into, write 1 minus x power 50 as 1 minus of 1 minus x power 50. Then multiplying inside 50n into integral 0 to 1, 1 minus x power 50 whole power n minus 1 into 1 will be in minus 1 minus 50n into one minus x power 50 whole power n minus 1 into 1 minus x power 50 will be 1 minus x power 50 whole power n. Integral 0 to 1, 1 minus x power 50 whole power n is in. So, 50n into in. Now, we got some relation between in and in minus 1. From this, we have to find the ratio. Taking 50n into in to left hand side, you will get 50n plus 1 into in. See, this is 50n, this is in. Adding these two, taking it this side, you will get 50n plus 1 into in is equal to 50n into in minus 1. Now, in the given question, we want in minus 1 by in. So, in minus 1 by in is equal to what? 50n plus 1 by 50n. Now, what is the value of n here? 101. Putting n is equal to 101. You will get I 100 by I 101 is equal to, substituting 101, what will get, numerator will be 5051, denominator will be 5050. Then cross multiplying by 50, or what is the given question? 5050 into in minus 1 by in, I 100 by I 101. So, cross multiplying this, what will get? 5050 into I 100 by I 101 will be the answer. 5051 is the answer. Okay. Next question. If in is equal to integral minus pi to pi sin nx by 1 plus pi power x into sin x dx for n is equal to 0, 1, 2, 3 and so on, which of the options are correct? One or more choices are correct. Now, first, if sin 1 plus pi power x is not there, then we know the approach for sin nx by sin x. So, how to get rid of this 1 plus pi power x? When the limits are minus a and plus a, you check whether the function is even or odd. Sin nx by sin x is even function, replacing x by minus x, sin nx by sin x remains same, but 1 plus pi power x is neither even nor odd. So, the whole function is neither even nor odd. If the function is neither even nor odd, when the limits are minus a and plus a, what is the approach? We have to use the property that x should be replaced by a plus b minus x. What is a plus b minus x? Minus pi plus pi minus x is minus x. So, this integral remains same. by replacing x by minus x. So, first you write In is equal to integral minus pi to plus pi sin nx by 1 plus pi power x into sin x. So, using the property replacing x by minus x, it remains same, minus pi to plus pi, sin nx by sin x remains same. Here denominator will be 1 plus pi power minus x. Into sin x. Now, if you write pi power minus x as 1 by pi power x and take LCM in the denominator, it will become minus pi to plus pi power x by 1 plus pi power x into sin nx by sin x. What will you do now? Whenever you apply that property, you have to add the integrals. So, adding this In and this In, 2In is equal to integral g minus pi to plus pi is common, and sin nx by sin x is common, and adding 1 by 1 plus pi power x and pi power x by 1 plus pi power x, you will get 1. So, 1 plus pi power x is eliminated, you will get sin nx by sin x. So, In is half of it, and we know the approach for this question. If sin nx by sin x is there, we know what to do. But before that, since the function is even, let us write it as 2 integral 0 to pi, property of even function, 2 integral 0 to pi sin nx by sin x, right. So, 2 cancels, we get In is equal to integral 0 to pi sin nx by sin x. Now, what is the usual approach? In minus 1 we have to find. It will be integral 0 to pi, denominator is sin x, numerator is sin nx minus sin n minus 1x. What is sin c minus sin d? 2 cos c plus d by 2. C plus d by 2 is 2n minus 1 into x by 2 into sin c minus d by 2. C plus d by 2 is 2n minus 1 into x by 2. C minus d by 2 will be x by 2. That means this sin x is not getting cancelled like the previous questions. So, what we do? We observe the options. In the options, first option is In is equal to In minus 2. Okay. So, instead of subtracting In minus 1 from In, let us find In minus 2. Then this will be n minus 2. Then what happens? Sin c minus sin d is 2 cos c plus d by 2 will be what? N plus n minus 2, 2n minus 2 by 2 will be n minus 1 into x into sin c minus d by 2 will be x by sin x. Now see, sin x cancels. So remember this, usually we try in minus 1 that is the general approach, but sometimes if it is not working, then check in minus 2. Now what is the integral of 2 cos n minus 1 x? It is 2 sin n minus 1 x by n minus 1, and substituting limits 0 and pi. What we will get? Substituting pi, sine of n minus 1 into pi is 0 and sine 0 is 0. So it is completely 0. in minus 2 is 0 means in is equal to in minus 2 for all n. That means I1 is equal to I3, I3 is equal to I5, I7 and so on. Similarly, I2 is equal to I4 is equal to I6 is equal to and so on. Okay. So now let us see the options. First option is correct. Since one or more are correct, we have to check the other options. This is sigma n varies from 1 to 10 I 2n minus 1. Sigma n varies from 1 to 10 I 2n minus 1. This is I1 plus I3 plus I5 plus and so on, 10 terms. But we know that all are equal. So let us find I1. What is I1? Finally, we got In as this. If you put n is equal to 1, what you will get? Integral 0 to pi 1 dx, that is pi. So I1 is pi. If I1 is pi, what is this sum? 10 pi. All these are equal to pi. So 10 terms are there. So 10 pi. So is it correct? Yes. Option B is correct. In option C, sigma I2n, n varies from 1 to 10, means n varies from 1 to 10, sigma I2n. Putting the values of n, you will get I2 plus I4 plus I6 plus and so on, 10 terms. So here let us find I2. I2 is equal to what? Sin 2n, let us take this. I2, putting n is equal to 2, sin 2x by sin x. What is sin 2x? Integral 0 to pi, sin 2x by sin x is 2 cos x. Because sin 2x is 2 sin x cos x, no? Cancelling sin x, you will get 2 cos x. If you calculate, integral of 2 cos x is 2 sin x, and substituting limits, what will you get? 0. I2 is 0 means I4 is 0, I6 is 0, all are zeros. So if you add 10 zeros, you will get this sum as 0. So this option is correct. Next option is In is equal to In plus 1. Obviously it is wrong, because already we have proved that In is equal to In minus 2. Okay. And also we observe that I1 is not equal to I2. So that is fourth option is wrong. Let us proceed to next question. Yeah, this is an excellent question, previous JEE question. This is based on integration as limit of a sum. First, let us write let us take limit n tends to infinity, and we may call it as limit n tends to infinity of Sn. If you want, you can write it as S infinity. It is equal to limit as n tends to infinity sigma n by n square plus kn plus k square. K varies from 1 to n. In definite integral as the limit of a sum, what is our formula? Limit n tends to infinity 1 by n sigma f of r by n. R varies from, what are the limits? You can take either 0 to n minus 1 or 1 to n, we have discussed it, or even if you take 0 to n, you will be getting this as integral 0 to 1 f of x dx. This is our formula. In place of r, if you take k, then also it is equal to the integral 0 to 1 f of x dx. Now, if you want to use this formula, first we have to take get 1 by n before sigma. How to get 1 by n here? Take n square common from the denominator. Then it is equal to limit n tends to infinity. If you take out n, if you take n square common, one n will cancel from numerator. So remaining will be 1 by n. Write it outside. 1 by n sigma, k varies from 1 to n, 1 by, taking n square common, what we will get? 1 plus k by n plus k square by n square. 1 plus k by n plus k square by n square. Now clearly it is in the form of f of k by n. Then what is the working rule? Replacing r by n by x, it becomes f of x. Similarly here, replacing k by n by x, you will get the function 1 by 1 plus x square integral and dx. How to get the limits of x? X is nothing but k by n. So limits of x are nothing but limits of k by n. Divide the limits of k by n. You will get 1 by n to n by n. If n tends to infinity, 1 by n means 0. Lower limit is 0, upper limit is 1. Okay. And similarly, if you take Tn for n tends to infinity, limit n tends to infinity, Tn is equal to, if you proceed in the same way, only the limits will be different. Okay. What will get? Limit n tends to infinity 1 by n sigma 1 by 1 plus k by n plus k square by n square. K varies from, here k varies from 0 to n minus 1. Then if you convert into different integral, again you will get the function as 1 by 1 plus x square. And what will be the limits of x? Divide the limits of k by n. 0 by n is 0. N minus 1 by n will be 1. N minus 1 by n is 1 minus 1 by n. 1 by n tends to 0. So the upper limit is 1. So if n tends to infinity, both this and this are equal, then for some value of n, for n is equal to 1, 2, 3 and so on. Sorry, here this must be less than, this is also less than. Now, for some value of n, we have to identify the correct answer. Now, let us see how this sum and this sum are calculated. Let us draw the graph of this function. We want to find out this area, the definite integral means we have to find out the sum of the values of this function or area. How is this function? Let us take f of x is equal to 1 by 1 plus x square. How to draw the graph? If you find f dash x, f dash x will be u minus 1 by 1 plus x square whole square into 1 plus 2x. What is the interval? The interval of integration 0 to 1. In the interval 0 to 1, this is less than 0 for x belongs to 0 to 1. That means it is strictly decreasing function. So, if you draw the graph, at 0, what is the value of the function? F of 0 is 1. I will take 1 here. Next, at 1, what is the value of the function? 1 by 3. 1 by 3 will be around here. Now, what is the direction of concavity? F dash x is negative, so it is decreasing, and direction of concavity is upwards or downwards. If you check, actually we have to find the second derivative and check. If the second derivative is negative, concavity is upwards. If the second derivative is positive, concavity is, if the second derivative is positive, concavity is upwards. If the second derivative is negative, concavity is downwards. But instead of finding second derivative, just you join these two. If the concavity is upwards, it will be like this. If the concavity is downwards, it will be like this. So, take midpoint of this line segment. This point is 1 comma 1 by 3. This point is 0 comma 1. What is the y coordinate of the midpoint? It will be 1 plus 1 by 3 by 2. How much? 4 by 3 by 2 means 2 by 3. This is 2 by 3. Substitute, what is the x coordinate of the midpoint? 1 by 2. Now, substituting 1 by 2 in the function, 1 plus 1 plus 1 by 2 plus 1 by 4. How much are you getting? If you get more value than 2 by 3, concavity is down. If you get less value than 2 by 3, concavity is up. What is this? 1 by 1 plus 3 by 4, that is 7 by 4. So, it is 4 by 7. It is greater than 2 by 3 or less than 2 by 3. How to check? 4 by 7 and 2 by 3 we have to compare. Multiply both sides, both the numbers by 21, which is LCM of 7 and 3. This will be 12, this will be 14. So, this is smaller. So, at this point, at x is equal to 1 by 2, the point on the curve is below this point, means concavity is upwards. Okay. So, I will remove this. The curve is like this. Okay. Now, this definite integral, which one? Integral 0 to 1, 1 by 1 plus x square is nothing but this area. Now, you can calculate the area or sum of the values of the function by dividing this interval into n equal parts. So, divide this interval into n equal parts. Like this. Now, here let the width be h. H is equal to b minus a by n. If you divide this one, total length is 1. If you divide into n equal parts, each part will be 1 by n. Okay. Now, what is the first ordinate? F of 0. What is the second ordinate? F of 0 plus h, that is f of h. Next is f of 2h and so on, last is f of nh. Now, in Sn, k varies from 1 to n, means you are starting from second ordinate. If you start from second ordinate means f of 1, f of h, f of h into this h, this area. For k is equal to 1, you will get this area. For k is equal to 2, you will get this area. In this way, if you add up to f of nh, what will get? This is the shaded area, in the same way, is the value of Sn. Now, clearly that sum of the shaded areas is sum of the rectangles is less than the actual area bounded by the curve f of x and x axis in the interval 0 to 1. Let us calculate this integral. How to calculate this integral? You know, you can write this as integral 0 to 1 by, write it as a perfect square. We can write x plus 1 by 2 whole square plus 3 by 4. Integral of this is 1 by a tan inverse x by a formula. If you calculate, you will get pi by 3 root 3. The integration part you calculate. Sum up to infinity is pi by 3 root 3. But you are not taking up to infinity. You are taking the sum for some n. Then what happens? The sum of these rectangles, which is equal to Sn, will be less than the actual area, because everywhere you are ignoring some area. Therefore, Sn will be less than pi by 3 root 3. Option 1 is correct. Now, let us check for Tn. In Tn, you are taking k from 0 to n. If you take k from 0 to n, you will first take f of 0. F of 0 into h will be, first ordinate into h will be this area. You are getting some more extra area. Similarly, second ordinate into h, you are getting some extra areas up to, you are taking the first ordinate into h, second ordinate into h and so on, you are adding the areas of the rectangles. So, last but one ordinate into h will be this area. So, if you add all of them, you will get Tn, which is clearly more than the actual area. So, Tn will be greater than pi by 3 root 3. So, first option and fourth option are correct. Next question you can do integral 0 to pi sine 2x by sine x, you try, prove that it is 0. Just take in minus 1, okay, in minus 1 will be 0, okay. Then in is equal to in minus 1, taking n is equal to 1, if you calculate you will get the answer 0. Next is integral 0 to pi by 2 sine square nx by sine x. We know the approach, denoted by in, integral 0 to pi by 2 sine square nx by sine x. Okay. So, we have only 10 minutes left approximately. So, I will just explain the method. In minus 1. If you take, I will write direct steps, integral 0 to pi by 2, denominator is sin x, numerator will be sin square nx minus sin square n minus 1x will be sin 2n minus 1x into sin x. sin x cancels. Then if you integrate, you will get integral 0 to pi by 2. What is the integral? Integral sin 2n minus 1 into x will be cos minus cos 2n minus 1 into x by 2n minus 1. Substitute the limits 0 to pi by 2. You will get 1 by 2n minus 1. Okay. In minus 1 is 1 by 2n minus 1. Now you try this question. If you take n is equal to 1, you are getting first term. If you take n is equal to 2, you are getting second term. Okay. That means putting n is equal to 1, 2, 3 and so on till n and adding LHS and RHS, then you will get In is equal to that. Okay. Next question. This already we have done before this. I is equal to integral 0 to pi cos x by x plus 2 whole square. Then and I1 is equal to integral 0 to pi by 2 cos x sin x by x plus 1. Then evaluate I1 in terms of I. Let us take I1. Multiplying and dividing by 2, numerator becomes sin 2x. And denominator becomes 2 into x plus 1 is 2x plus 2. Now, whole function is in terms of 2x. So, I will use f of kx formula. What is integral a to b f of x k f of kx dx? 1 by k integral ka to kb f of x dx. So, 1 by k means 1 by 2, ka to kb means we have to multiply the limits by 2. So, you will get 0 to pi, you will get sin x by x plus 2. Okay. Now, to calculate this further, we have to express it in terms of I. We want x plus 2 whole square. So, what we will do? Let us integrate it by parts. Taking 1 by x plus 2 as first function and sin x as second function. Then half into first function into integral of the second function. First function is 1 by x plus 2. Integral of the second function is minus cos x. Limits 0 to pi. Okay. Minus integral 0 to pi derivative of the first function into integral of the second. Derivative of the first function is what? Derivative of 1 by x plus 2 will be minus 1 by x plus 2 whole square into integral of the second function is minus x. So, it becomes minus cos x. So, it becomes plus cos x by x plus 2 whole square, which is I. Now, calculate this. Half into substituting pi, cos pi is minus 1. So, 1 by pi plus 2, okay, minus substituting 0, minus cos 0 is minus 1. So, this becomes plus 1 by 2 minus I. Okay. If you want, you can simplify further. And next question, if In is equal to integral 0 to 1 x power n tan inverse x dx, prove that some relation between In and In minus 1, In minus 2. Here just substitute In and In minus 2, you will get it. N plus 1 into In is integral 0 to 1 x power n tan inverse x plus n minus 1 into integral 0 to 1 x power n minus 2 I n minus 2 x power n minus 2 tan inverse x dx. Now, let us take integral 0 to 1 tan inverse x into x power n minus 2 common, x power n minus 2 tan inverse x common. Here you will get n plus 1 into x square plus here you will get n minus 1 into 1 dx. Okay. So, now you can write it as x power n minus 2 tan inverse x into nx square plus n will be n into x square plus 1 plus x square minus 1. Okay. Now, multiply it inside and calculate the integral. You will get pi by 2 minus 1 by n. Time is up. So, we are going to conclude the session for today. So, let us continue our last lecture in definite integration in the next class, and then we are going to move to next topic, ellipse. We are now taking up coordinate geometry. Okay. Thanks for watching. See you in the next class.